right, guys, are there any questions over the homework? Questions over the homework assignments? Okay. What we're looking at today is ellipse or ellipses. So ellipses are kind of like circles, they're just more ovular. One side is going to be more elongated than the other. So the radius, we don't have a radius. We don't have a set length from the center to any point on the circle. Now there's two ways it can be stretched. It can either be stretched horizontally or vertically, are the two main ways. And the way that it stretches, or the amount that it stretches, is going to be our A and B values. And A is always going to be greater than B with ellipses. The value of A is always going to be greater than B. So if it's stretched horizontally along the x-axis, A is going to be with x, as we see here. If it's stretched vertically, A is going to be under the y value. They go together. Now we don't have to write y first or x first. It doesn't matter how we write it, as long as the direction that it's stretched, it goes with the correct variable. Now, sometimes we're not given A, B, and C because the foci are going to be C, and they're going to be along the vertex, or along the line with the vertices, with both of these here. Foci and vertices are on the same line. Co-vertices go in the opposite direction. So if we're given the foci and vertices, we're going to have to use this equation here to find the value of B for the minor arc, minor length. Now the first thing we're going to be doing is finding the equation of the ellipse from the given data. One thing that's going to be the same with all these here is that we're going to have y minus h squared plus x minus, so x minus h squared and y minus k squared. Those are going to be the same. The only difference between the two is where a and b squared are located, which one it's going to be under. Now when we look at this first one here, we need to determine, is it stretched horizontally or vertically? Is it stretched longer across the x or across the y? Y. So that means a squared is under the y, b squared is under the x. If it was stretched horizontally along the x, it would go the other way. Questions on this here? So we have the equation. Now this parts or piece of information we need is we need the center. We need to know the location of the center, the value of A, and the value of B. Because if we have these three pieces of information, we can get the equation. If you'll pull the door. Now looking at this here, the center is at what point?
Please release 8 students at 1 to go to the community center. Brandy
0, 0.
Tanner Rivas, Reagan Hafford, Felicia Lewis, Callie Goodman, Anila Pendry, Kylie Martin, Mina Yang, Chloe Voss, Kimberly Salinas, Kinsey Boyd, Avery Reese, Austin Enos, Brandon Shelley, Malachi January, Jessica Martinez, Davian Andrews, and Saber Hagner. Again, release them at 1 to go to the community center. Thank you.
Now A, since we said it's stretched longer along the y, A is going to be the distance from the center to the vertice. And this length here is 9. So the value of A is 9. And we consider the major length would be from vertice to vertice, which would be 18. Now our B value is going from the center along the x-axis. Do we know what this length is? No, and it doesn't give us a good point on the x-axis either. However, there is another length that we do have. And it's this one here, which is our C value, which is 7. So at this point here, we need to find the value of B. Let's see, use purple. So we'll use the equation A squared is equal to B squared plus C squared to find the value of B. And we can plug in our values. So a is 9, so we'd say 9 squared is equal to b squared plus 7 squared. Well, 9 squared is 81. So we're saying 81 is equal to b squared plus 49. At this point here, we can subtract 49 from both sides, telling us that b squared is 32. And last but not least, we can square root both sides, saying b is equal to the square root of 32. Now that will reduce. We could reduce it to 4 square root of 2, but it doesn't really help us in this case here. Any questions on how we found any of the information so far? Now we just need to plug it in. So we can say x minus 0 squared over b is the square root of 32 squared plus y minus 0 squared over 9 squared is equal to 1. Now we can simplify some of this here because x minus 0 squared is just going to be x squared. Square root of 32 squared is just 32. Y minus 0 squared is just y squared. 9 squared is 81. And we have this here. That's it. Questions on anything we've done so far? So this isn't too bad as long as we find the values of a and b. If we find the values of a and b, we have the equation pretty easily. Well, we don't need to do this one because that's the exact one we just did. So let's look at this next one here. And again, we want to find the equation. So we have our x minus h squared plus y minus k squared, bless you, is equal to 1. Now, if we notice, they did give us the vertices and co-vertices already. They gave us those. They didn't give us the foci this time. And where they intersect is the center. So here the center is the point 0, 0. Not always, but the number that doesn't change for the vertices and the number that doesn't change for the co-vertices, those two together will give us the center. So if we look at the vertices, 0, 5, 0, negative 5, well, the number that didn't change was so it's the x-axis. And since it is the x number for both, it's the x number for the center. If we look at the co-vertices, negative 3, 0, and 3, 0, well, the number that didn't change was the 0 and y, so that's the y value of the center. And we can use that even if it wasn't just 0, 0. Now, if we look at this distance here, this distance is, so A is, and B is, A is 5, B is 3. We don't even need to know what C is, because we already have A and B. And is it stretched more along the y or the x? So A squared would be under y, B squared is under Now we can just fill our information in. So we'd have x minus 0 squared, bless you, over 3 squared plus y minus 0 squared over 5 squared is equal to 1. X squared over 9 plus y squared over 25 is equal to 1. Once we find the values of a and b in the center, we have the equation. Yeah, if you get C instead of B, you just got to use the equation to find it. No. Any questions on this here? Do we need to see another example of one of these? It's the same thing. We are provided the foci and vertices, so it's the exact same thing, except this time it's stretched along the x instead of the y. Let's look at the next one here. We'll look at some of those that we just did where the center isn't 0, 0 next. We're going to finish up the ones where the center is 0, 0 first. Now, part of the reason I know that the center for this is 0, 0 is looking at these here. Now, we're not going to find the foci, and part of the reason I say that is because the foci for most of them isn't nice. If A and B are nice numbers, the foci isn't. If the foci in A or foci in B are nice numbers, then the other one's not. And we'll find A and B first, and then I'll do C off to the side here in a minute. But what we want to find for this here is the vertices, co-vertices, center, and we'll talk about the orientation. For this here, it's easiest to find the points first, or the center, and then A and B first, and then we can use the graph to find the rest. Okay? Now the center is our HK. Well, H and K are always located with X and Y. Yes? There's no number with it. Exactly. So 0, 0 is our center. And on the graph, it's right there. So exactly, a squared is, for ellipses, always the bigger number. So it would be, and b squared would be 49. Now at this point here, we would take the square root of both of these, telling us a is 8. Square root of both sides, and b is, okay. I'm going to pause it here. So, any questions on how we found A or B? Now again, we said A and B, so the major length is what it's attached to. So since A is attached to Y, that means the major stretching is going to be on the Y, yes? So from the center, we can go up and down 8, that length. 1, 2, 3, 4, 5, 6, 7, 8, which would give us the point 0, 8. We can also go down 8. 1, 2, 3, 4, 5, 6, 7, 8, which would give us the point 0, negative 8. And the one that is the farthest that's dealing with A would be our vertices. So 0, 8, and 0, negative 8. Now our co-vertices would be going the other direction. So that would be dealing with our value of B. So we'd go over 1, 2, 3, 4, 5, 6, 7, which would give us the point 7, 0. We would go 7 the other direction. 2, 3, 4, 5, 6, 7, which would give us the point negative 7, 0. And those would be our co-vertices. And there's our graph. Questions on this here? Do we need to see another example with this here? These are kind of nice. As long as we're not having to find the foci. Okay. Now we can see here they gave us the two foci and the two vertices, because the only points that are significant inside the ellipse are the foci. So the foci, or the center, is always going to be in the dead center of the vertices and the foci. So the center for this here will have a y value of -6 because it's along that line. It has to have -6 as the y value of the center. But it's also between the x value of 0 and 8. And it's going to be in the exact middle between the two foci. So what's the middle between 0 and 8? 4, yes? If we look at the other one, -3 and 11. Well, -3 plus 11 is 8. 8 divided by 2 is still. So the center is the point for -6. And it'll always be in the middle. Now the equation we're working with is x minus h squared over and y minus k squared is equal to 1. A and B, so yes. Since it's stretched along the x-axis, it's under x. Now we do need to find A and B. Because we found h and k, we could, if we wanted to, plug those in already. Because it'd be x minus 4 squared over a squared plus y minus -6 squared over b squared. So A, distance from our center to the point over here is 7. So A is 7. But we don't have B. It looks like it's this here, which is 6 possibly, but we're not sure. I did that, especially I wanted to assume that first hour, but it doesn't work out that way. But we do know what C is. C is from 4 to 8 is, so C in our case is 4. And again, as we've seen already, if A and C are nice numbers, most likely B is not. For some reason, that's how it just works out for most of these here. So we have our A squared is equal to B squared plus C squared. Well, A is 7 squared is equal to B squared plus 4 squared. Now in this here, 7 squared is 49, and 4 squared is 16. At this point here, we're going to subtract 16 from both sides, telling us that B squared is equal to 33. And exactly, when we square root both sides, B is the square root of 33. And we can plug this in. And when we simplify this here, we'll have x minus 4 squared over 49 plus y plus 6 squared over 33 is equal to 1. So it was, B was almost 6, almost 3 points off. Because if it had worked out to be the square root of 36, then b would indeed been 6, and that would have been nice. Questions on this here? Questions on anything we've done so far? Now, I will say this with hyperbolas, or not hyperbolas, these ellipses. These here are actually kind of useful, because especially around here where you're building pens or corrals, this kind of ovular shape is actually kind of nice, and they're actually easy to make. Because if you can set the center of where you want it in this distance here away from it, if you can get those two and the value of a, what's interesting is that this distance here, from here to here, is, for this problem, 14. It's twice a. Okay, that's fine, that's interesting. Distance from here to here is still 14. Any of those distances from the foci to a point on it to the other foci will be twice a. So what that means is if you find the center of where you want it and get the two foci, you can actually plant two stakes in the ground where the foci are and take a rope and attach it to it that length and trace it out. And you can actually trace out an ellipse very easily with that. There. The only one easier than an ellipse is a circle. So you just put a stake in the ground, your set length, and then draw a circle. Let's look at this here. This one here is actually easier if we have the vertices and co-vertices. Now our starting equation, we can put most of it down. X minus h squared plus y minus k squared is equal to 1. And again, our a squared and b squared, a is always going to go with the one where it's stretched the longest. If it's stretched longer across x, it's going to go under x. If it's stretched longer across y, it'll go with y. And it's going to be across y. Now, since we're given the vertices and co-vertices, we're going to have a and b. We don't have to deal with c. C is only with the foci. Now, looking at the vertices, which number changes? The y value changes, yes? So that means the one that doesn't, the x value of 6, is the x value of the center. The co-vertices, the -2 doesn't change in the y. So that's the y value of the center. It works out nice that it does work that way. And we can plug those in. So we can say x minus 6 squared plus y minus -2 squared. And again, a is going to go with the vertices. And it's really going from the center to one of these vertices. So looking at 6, -2 to 6, -8. So the difference between -2 and -8 is? So what we're saying is -2 minus 6 gives us -8. And -2 plus 6 would indeed give us 4, the other vertice. Now to get b, we're really going from the center to our co-vertice. So we're looking to see what's the difference between 6 and 9. Because if we said 6 plus 3, 6 plus our value b, we would get 9. And 6 minus b, 6 minus 3 would indeed get us 3. Now we can plug them in. So we would have 3 squared, 6 squared, simplify. X minus 6 squared over 9 plus y plus 2 squared over 36 is equal to 1. Now, if it did work out that the A and B values for these were the exact same, it wouldn't be technically an ellipse, it would be a circle. Questions on this here? Do we need to see another example of one of these? We ready for the last type? So, again, we're not looking at the foci, and we'll do it additionally outside of the video to show you kind of why I removed it. But the main things we need to find is the center. We will find the vertices and co-vertices. But what's really helpful for finding the vertices and co-vertices is the values of A and B after we find the center. The center is given to us from the numerators of both of these here. And when we pull the values out, we kind of have to flip the sign. Since it says -3, the x value of the center is +3. Since we have -9 for y, it is +9. It's shown it to us as we've done, like on the last one. We had a positive x value inside the equation, it looked negative. We had a negative y value, it looks positive. So 3, 9. So there's our center. A squared is our bigger of the two denominators, which would be 16. B squared would be the other. Square root. So A is 4. Now, since A was connected with the, bless you, x, it means it's longer across the x. So from the center, we can go 2, 3, 1, 2, 3, 4 to the left, and we can go 1, 2, 3, 4 to the right. Since this was 3, 9, our two vertices are going to be 7, 9 and -1, 9. I did get asked earlier today, does it matter the order we list the vertices? No, because I could have listed 7, 9 first, or I could have listed -1, 9 first. It doesn't matter as long as we have both. Co-vertices is up and down, so we're going to go up and down 2. Down 2. Up 2. So we would have 3, 11 and 3, 7. And last but not least, we would connect those points. Other than that, that is it. No. Yes. You're welcome. So on number 8, on problem 8, so if you go flip over to number 8, the top two numbers, 5, 6, 6, 9, those are actually the co-vertices. And the co-vertices, you could just mark out co. Those are the actual vertices. I had them flipped. That's yours. So we have that. Now, 9, 10, 11, and 12, you do not have to find the focus. So you can mark that out. You do not have to find the focus on 9 through 12. So the top two numbers, 5, 6, are the covertices, and 7, 9, and 7, 3 are the vertices.